Part A. It's, again, really important to understand key lingo, like Rolando is going at least 40 miles. That means he could drive 40 miles exactly or more than 40 miles. So that we're probably looking at something like a greater than or equal to 40, but less than 60 miles. So he can't actually go as far as exactly 60. That would be strictly less than 60. And I think another thing that you have to, make sure when you read, you get a grip on it and reading comprehension deal each week. So it's 40 miles. It's at least 40 miles, but less than 60 miles every week, and then the graph is going to represent 8 weeks. All right? So every week it's like he's driving between 40 and 60, but it could actually be 40, but not exactly 60, but still kind of like an in-between thing. But the graph is going to be for 8 weeks. So real quick, what you're just going to do is do like 8 weeks times that 40 miles. And that should be 320 miles. So like he's going to be going at least 320 miles in 8 weeks. And then the 8 weeks going, almost as high as 60, but not quite there. That's going to be 480 miles. So we graph the 320 and the 480. All right? But we could have gone at least 320 miles in the 8 weeks. And so that means, watch. That means we're allowed to equal 320, and that's going to get a closed circle, a closed point on this graph. But we're not going to fill in this circle because we want to be strictly less than 480. Like we could go as high as 479. We could even go as high as 479.9 miles, but we're not allowed to include the exact value of 480. So it gets bottom line, it gets an open circle. So this lingo resulted in an open circle on your graph. This lingo resulted in a closed circle. And again, we're doing like an in-between type gimmick where we're like greater than or equal to 320, but at the same time we're less than 480, and so like that's in between. So there's that final graph. And we have an explain question. Explain why. I guess I sort of just did. Explain why you chose to use the symbols for the endpoints. They're talking about the open circles. Well, the one was an open circle and the one was a closed circle for that compound inequality. And really quick, this is a compound inequality. It's a combination of the number of miles being greater than or equal to 320. And so, I just wanted to throw that out there. Like, technically, the word to connect, well, I'll kind of write it down. Should we use X? Maybe we'll use M. Let's use M. M is greater than or equal to 320. And M is less than 480. And because of this word and, normally we do this whole where we smush the two inequalities into one compound inequality. That's normally what you'd see. Anyway, that's just a little more notes on a compound inequality. And there's explanation, I guess, that I wrote down at some point. I used a closed circle for my left endpoint because at least 40 miles implies that the number of miles driven in a week could equal 40. And I used, yep, this should do the trick. Something like this. Remember to always be extra thorough. Part C. So Rolando buys. Once again, gang, we have this. Choose this color. We're using some inequality type lingo. So you got to be ready for words like at least, at most, no more than, whatever. So Rolando buys at least 8.5, but no more than 11 gallons of gas each week. The price of gas has ranged from $2.40 to $2.65 each week. Write an inequality to model all the possible amounts of money M Rolando spends on gas each week. So I guess here we're using M for money. What did I use M for back here? For miles. Okay, so I used an M variable back here for number of miles, and now it's going to be money. Just don't get confused, all right? That's all. That's all I'm saying. Don't get confused. So here M means money. All right, well, hopefully you've already thought about this, tried it. I guess if you're stumped, here we go. So an overall range, is that the word they used? I guess. Wait. Well, they just used all the possible amounts, whatever. So, but it is kind of, it is going to be sort of like an interval, right? Like from like what's our low amount of money we could spend, and like what's a high amount. Well, if we were going with a lowest possible amount, wouldn't that be, like 8.5 gallons that we were able to purchase for $2.40 per gallon? Like, wouldn't that be the lowest possible combination? If you were kind of like, so 8.5 gallons would be like the low, and we could multiply that by 240 per gallon, and that would be like the lowest possible, the absolute lowest possible amount of money that Rolando would spend each week on gas. And likewise, the highest possible amount of money, you would have to take the 11 gallons of gas as a high times the $2.65 price per gallon as a high. Like, that would be like the absolute highest possible. And when we do that, we get $29.15. So that's kind of like the interval. Now they want you to write an inequality, and in order to represent sort of like a range or like an interval of values, you should know that inequalities that'll do that look like this. It's a compound inequality where, M is greater than or equal to $20.40. Maybe I should have included dollar signs and a zero right here. Maybe I should have, I don't know. But probably. In fact, why the heck not? Hey, there we go. Hey, it's Robin Hood from the movie. If you hear that music in the background. They weren't supposed to know that. Whatever. Okay. Anyway. So again, this is a compound inequality, which means that the amount of money is greater than or equal to $20.40, but at the same time, it's less than or equal to $29.15. Like, that's all the possible monies that could be spent. So again, this type of compound inequality has like an in-between. Like, all the amounts of money are in between $20.40 and $29.15. And this part wanted you to show or explain all of your work, and I think I did that. Like I made sure to include all the units. That helps to guarantee you get like full points. So showing all that work, showing all that. I'm trying to think if there's any other work I could have shown, but I can't think of anything right now. So I'm going to say that we are done.